Halo, apa kabar semuanya? My name is Vincent. So now I'm going to talk about lesson 4, basic pattern for data analytics, HR retention prediction. And in this tutorial, we're going to talk about training multiple classifiers and evaluate them. Alright? So for this kind of tutorial, I'm not going to ask you to type it out with me, but we will try to see what other things that we can do with these models so that we can find those that are the most accurate. So what I do here is that I put in a bunch of different models that are doing classifications. Okay. Then after that, I put it inside a list. I initiate them one by one. So once they are initiated, then I do a for loop. So what this does is that it actually runs this in a loop. So it runs this for k-neighbors classifiers, do all the necessary runnings, and after that SVC, do all the running until all the Ds in these classifiers are all um, exhausted. So therefore, it will, and after that, print out the results. So in the end, then we get these results. However, this doesn't say anything much because we do not visualize them, so we cannot see which one is the best. So what we do is that we can do like bonds bar plots. So that's what I do, and then create two charts. So basically one for the classifier accuracy and classifier log loss. So accuracy, what it means is that how accurate it is from the predictions to the comparison of the real value or the actual value. And you can see here that random forest classifier is the most accurate with the predictions of, where's the random forest? At 98.83%. So that's a very good classification. And regarding the log loss, it actually gets, one of the lowest. So what does log loss mean? Well, in simply put, it's actually a very computer science kind of terms or statistical terms, quite advanced. But simply put, is basically how close is the model is from the probability of the real values. So they can be done by using the distance. So the distance of the model to the plots and to the classifications and so on. And the goal here is to have as as um, less log loss as possible, because that means that your model is actually quite far from the truth. Something like that. That's why that you want to minimize the log loss, because you want to sort of as much definitive model as possible. Okay, in spite of just accuracy. So in this case, you are going to choose random forest classifier. So what we do is that we created another fabric CLF classifier, random forest classifier, and we train them. And after that, we predict them. And when we predict them, then basically we put them inside a data frame. And finally, we see the prediction results. So, oops, we do random forest. Okay, let me run this again. It might take a while. It might take a while because it's running it one by one. So I think it will take around like half a minute. But once it runs, then I can run this together with you, and you can see the results of the predictions. Okay. So give a moment for a while. I think it's a bit slow for SVC. Yeah, so it's printing out SVC now. Now it's way faster from the rest. And yep, there you go. So I hope that is it. Yep. And after that, you can just run this. You're going to have a classifier. It runs. And I want to see what is inside the submission, and there you go. So this is the employee ID, which is the index inside the test, and the predictions. So I predict that employee number 454 is actually going to leave. So maybe I can approach 454, or maybe I can do, well, I want to see who are the people that leave, so I the function is sort, but maybe try it out. There you go. And then if I want to make it a descendant, so sending false. Oops. So there you go. These are the employee IDs that the machine predicted that they will leave. Okay. Alright, and I put it as submission. These are a lot of people. So as a goal, we want to approach them and maybe like increase the salary, or maybe like somehow increase the satisfaction level and so on. Alright. So with that, let's just run it again. And finally, we want to evaluate the prediction result. How close and how far is it from the prediction results? So I did another data frame. So I put it as a result. And let's just view what this result is. So for employee 2959, so the prediction is 0. For employee 12160, the prediction is 1. So as you can see here, there's left is the actual value. Prediction is the predicting the left. Okay, so it doesn't know that what is the left value first before doing the predictions. So as you can see here, most of them are quite accurate. 0, 1, 1. It predicts 1 for the people that should have left. It predicts 1, 0 for people that do not leave. So it's quite accurate. But there are some cases where it's not accurate, and how we can check it is simply by just doing left equals or not equals to prediction. So results, and then I put a pointer, results, prediction, and oops. Okay, maybe I shouldn't do this. How about if I do it this way? And I think the prediction should be, the prediction should be capital P, that's why. Okay, so if I put this one, so I can see that this is quite some pictures, some numbers, some employees that that the machine predicted wrongly. I want to count how many. So you can just count how many, and there are 35. But this is good enough result considering that. Well, let's see how many submissions that we have. So how many? Okay. So print shape. So assuming that we have 3000 and we have, okay, this one plus 960. So how many rows there are? So we have 3000 data sets and 3000 employees inside the testing data, and out of this testing data, only 25 that the model predicts wrongly. But that means that it is a good setting because that means the model accurately predicts 2975 based on the historical data. So that is the benefit of machine learning. But of course, this data is just based on the historical period, always changes. Maybe working environment changes, and there are more predictors that can be done in order to make the model stronger. So it always needs to be tested out with the real life. But inherently, it gives you a very nice starting point for you to start approaching people and maybe increase their satisfaction so that they do not lose out. So maybe like we can do that by seeing the profiles of those people that leave. So we can do that by just that equals to prediction equals to 1. Okay. Okay. 50. I always forget 50. Yeah. So prediction equals to 1. These are the people. So start approaching these people. They have low satisfaction levels. I don't know why. It's still sad. But there's a good satisfaction level, but maybe overworked, or maybe like have something that is not represented in this. Well, this is actually working well. 12764. but he left, and the company figured he left. Maybe it's because the salary is not medium, so maybe this guy is expecting more. That's why he leaves. So feel free to test it out in this way, and then hopefully that you guys can understand more about analytics and how it can be used in HR. So in conclusion, let me go back to the top of the page. In conclusion, we have learned how to load the data, we have explored and understand the data set, we did department analysis, and we did the predictions of the retention of employees, and re-evaluating all these models to discuss which model that we should inherently use. Alright, which is random forest. Oh, by the way, random forest is basically like a decision tree, but it does decision tree multiple times with different predictors, set of predictors. Predictors are the variables that is used to train the model, and different set of samples. So it does it multiple times so that it actually tapping on the wisdom of community. So because like those that model that underperform will be compensated by the models that overperform, or maybe just performing really well. So it's actually working very good. As you can see, there's good accuracy here. But it's very hard to find out what went wrong if the model doesn't predict correctly, because we doesn't know it's a combinations of many different types of model with different predictors and samples. So we cannot really decide if what went wrong compared to the simple decision tree analysis. So that's all about what I want to say regarding the models. Challenges wise in the future, maybe we can talk about how to find optimum effective wage based on these employee retentions. Comparing with other companies' job perks, maybe you can use a bit of web scraping and web analytics to find out how you can better adjust your employee needs, good for recruiting maybe. And also we want to profile these employees which very likely to quit if they don't get promotions. So maybe for high earners, we want to see whether it's time for him to get promoted or not, so that he doesn't leave the company. With that, I would like to put an end to this tutorial step by step. Thank you so much for helping me out and always coming to this class. Feel free to put the comments below at the YouTube for the community, and I will try to answer whenever I can. With that, thank you so much for listening. Sampai jumpa, and see you in the next lesson regarding social media trend, Twitter, media, big data, analytics. Bye bye.